Hi everyone, welcome back to the channel. So in today's video, I'm going to be showing you a self-improving AI agent. What does that mean is that I'm going to give the agent a task. Once it's done, once it's finished, I'm going to store the experience. I'm going to try to make the agent learn from the experience and mistakes that it made in this run to hopefully avoid it in the next runs. That's how basically I'm going to make the agent interact with tasks and try to learn from them. This idea is similar to reinforcement learning, but it's kind of like just a loop to close the cycle and make the agent learn from its mistakes. A lot of research is being done on this topic to basically put the humans out of the loop as much as possible and make the agents as autonomous as possible as well. So first I'm going to implement this task, and then I'm going to test the agent. I'm going to give it some tasks to assess how well this self-improvement loop or algorithm works. So yeah, that's all. Enjoy the video, and I hope you learn from it. So at the beginning, we have the task, which is basically the question plus the tools that we give to the agent, right? Like what task is the agent actually performing? Then we have some sort of memory store, which is optional, but I added here so the agent will learn for future tasks when it's attempting the same task one more time. And here I'm going to store the past turns and the past lessons learned from the previous error that the agent has made. Then we have the main agentic loop itself. So the agentic loop is basically where the agent take turns trying to attempt the problem. So here I use Claude, some tools for demonstration like calculator, web search, Wikipedia, and Python for code execution. Then we have the error detection. So during the turns of the agent, so when the agent makes a decision to use a tool, we can detect whether there was an error in that agentic step. So there are 5 types of signals or 5 types of error that I started with. So there's structural, where basically the agent produced an empty response, or there's like a fundamental error with the structure of the response. Then there is grounding. For example, if the calculator says the answer is 5, then the agent reports 6 in its final answer. That's basically wrong. Then we have the answer match, which is basically how much the final answer matches the correct answer. So this is more like of a metric for the correctness. And then there is LLM as a judge, which judges other aspects as well of the completeness and the relevance of the answer as well. And there is tool failure. So when the tool gives an error due to some mistake from the agent by giving the wrong schema or the wrong input parameters. If actually the result is correct, then we return the final result, and we basically save the answer and save the lessons learned along the way. If not, which is the most common case, it's going to be for harder tasks and like less intelligent agents, one of these errors had happened. Classify the error type in further granularity or details like the reasoning chain break, hallucinated fact, incomplete answer, wrong tool execution error, timeout or time limit exceeded. There could be another list, or we could actually skip this step and stick with the 5 signals that we have at the beginning without fine granular response. But the granular signal just gives a stronger signal to the agent or stronger explanation to the agent on how it should correct itself. So now the corrector, it will basically, based on the error type that we classified, we then pick a strategy. So there are 6 strategies here. And we can actually attempt multiple of them, like in an iteration, depending on the complexity of the task or whether one of these succeeded. So first we have the decomposition. So if the task failed at first time, just try to decompose it into smaller subtasks. And there's actually a paper on that. Then there's the grounding, which is basically telling the agent strictly to stick with the citations, then alternatives. We explicitly tell the agent that this approach has failed, try a different approach. So approach X failed, let's try Y. Restricted tools. So for example, if some tool failed, maybe you can use a different set of tools, or we tell the agent to eliminate the tool that failed or use something else. Parameter fix. So if the agent used a different parameter for the tool, we tell the agent to use the correct parameter. Then simplification. If the agent tried some complex approach, we tell the agent to basically simplify the approach. It's not basically just prompting, but there can be multiple implementations for that. And then we give that correction back to the agent. So we give the context on how to solve the problem back to the agent, and then we just loop again. So this is basically a simple loop. Whenever the task gets completed, we go back to the result. We trace down what happened during the execution and the loop, and then we save the lessons learned to a memory store. And memory store in my case, just like a JSON file. So here it's like memory stored, but I stored the lessons here. So here's an example. So here I gave 4 tasks. You can add any task that you want, and what are the tools that are needed to solve this task. For example, here is like a calculation unit conversion. In this task, the agent used these tools. Try just the calculator tool because it's just a unit conversion task. And at the beginning, task failed because of this reason. Answer does not reference any data from the tool output. The answer may contain hallucinated information. Okay, so this is the diagnosis, and then we use the grounding strategy. So according to the calculator, the final result is 31. So here we're trying to reference the calculator. This is not necessary, but just an example of one thing that could go wrong. Because actually with such simple tasks, it's difficult to make a good LLM actually fail. Now the second task, what year was the first widely recognized public demonstration of the telephone that transmitted intelligible speech, and who gave the demonstration? Answer the format, year, person at the event. So the first time the agent tried the web search, Wikipedia lookup. Based on my research, the first widely recognized public demonstration at the telephone that transmitted intelligent speech was given by Alexander Graham Bell. So now it's not saying the exact same format that we want, and now it's telling it's LLM reflection, it's hallucination, because it actually some of the information is wrong, and it also didn't use our format. So the second attempt, it said that, and also incomplete, so the agent final answer format was wrong again. So now it is the diagnosis, and the confidence is high that was the case. And now we want the decomposition strategy. So now with the decomposition strategy, the agent actually went and divided the task into even smaller steps. If you can see here, like it's only 3 steps, but here it was more steps, like about 8 steps or 7 steps, which is what we want in the decomposition strategy. The agent self-corrected and actually got the format or the final answer that we want. And this is the agent final answer, 1876, Graham Bell at this exhibition. So this is the summary. So we had the first task, which is the calculation unit. There was a hallucinated fact, and the agent self-corrected. The second one, also there was a hallucinated fact about the telephone Graham Bell, and it took the agent 3 steps to correct it with a decomposition strategy. The first one, we used the grounding strategy. I actually could include more examples, like just to show for the whole strategies, but that's beyond like the current just demonstration. So yeah, so this is the basically the self-correcting loop, and how the agent uses it. So yeah, that was everything I wanted to share with you in this video. If you actually want to learn how AI agents work from inside in detail, not just like black box, then make sure to subscribe, check out this video. Thanks so much for your time. See you in the next one. Bye bye.